Hi, I'm Odessa Thompson. I'm a senior in the magnet program. I'm about to graduate, and here's my research project. Last summer, I went to MIT for a program specifically focusing in data science in health and medicine. I learned how to use big data to solve complex medical problems and train algorithms. This was my capstone project.
Now you've probably heard the words the opioid crisis or the opioid epidemic pretty often in the last couple of years. Maybe you think it's overblown or overhyped for something that's not that big. However, the opioid epidemic is in fact quite real and quite dangerous. There have been 3 significant waves of opioid usage, the most prominent and recent being synthetic opioids. These opioids are used to treat chronic illnesses like cancer, so we can't exactly just get rid of them. Most commonly known is probably fentanyl, but an even stronger opioid is carfentanil, which is sold usually on the black market and mixed with heroin. A few grains of this can tranquilize an elephant.
So what I did in my project was create a model that would predict a patient's risk of becoming an opioid addict or overdosing on opioids. So what is a machine learning model? Well, a machine learning model is an involving algorithm that finds patterns in data and outputs predictions about that data. And so our second question is then, how do you create a machine learning model? And that's where the fun begins. Our next step was gathering data. This may surprise you, but as high school students living in Boston for about a month, we weren't exactly allowed to go out and find real opioid addicts to survey. So we had to rely on large, anonymous online databases. Our first database was the National Survey on Drug Use and Health, an anonymous online survey given to participants around the country. This focused mostly on self-reported statistics like education level, socioeconomic status, alcohol usage, marijuana usage, and mental health. Our next database was actually reported by medical professionals about their patients from their intensive care units throughout the country. These had much more quantitative results, such as Apache score, previous prescriptions, discharge status, and age, gender, ethnicity. Next, after we had all our data, we cleaned it, which means going through each and every row and removing extreme outliers and changing all qualitative variables to quantitative variables. We did this using Python because there was thousands, if not hundreds of thousands, of data points and variables that we had to go through. Then our model had to be trained. A good analogy for this is taking a math test. Imagine taking a math test, going up to your teacher and checking the answer key. Maybe you'll learn a few things. Maybe you'll learn a new formula. Then the teacher gives you the same exact test except with slightly different numbers. You take it again. You check the answer key. You learn something. Now do that thousands and thousands and thousands of times, and maybe by the end of it, no matter what numbers your teacher gives you, you'll be able to get 100%. That's sort of how our model works. Except instead of a test, the model is trying to classify patients as either high risk or low risk for opioid risk disorder. We use 2 different types of machine learning models, but for your sanity and for your time, I won't get into them right now. So after all that, here are the results. A little bit anticlimactic, as it's just a bunch of numbers and a graph you might not really understand, but I'll explain. To really understand what these graphs and numbers mean, we first have to look at what a true positive is versus a false positive. A true positive is when our model correctly classifies someone who does have opioid risk disorder as indeed having opioid risk disorder. A false positive is when someone who does not have opioid risk disorder is classified incorrectly by our model as having opioid risk disorder. When we graph our false positive rate by our true positive rate, we get an ROC curve, which basically tells us how good our classifier is. As you can see in our results here, our drug use and health survey model was significantly better than our intensive care unit model. This is a little bit odd because the National Drug Use and Health Survey was actually self-reported, which many people think might make it less accurate. But in fact, in our model, it actually made it more accurate. This was probably due to the features we used, like marijuana usage, age, income, education level, as well as a variety of others. So what? This number is a little bit higher than that number. Why does it even matter? I thought we were trying to learn about opioids, not about data science. You see, one conclusion from all these numbers is that marijuana usage is actually a really good indicator in how likely someone is to misuse opioids, and in the opposite way that our current society actually believes right now.
Currently, a lot of people think that legalizing marijuana will actually decrease opioid overdose because marijuana is another form of pain relief. However, our research shows that current or past marijuana usage may actually increase your chance of having opioid risk disorder. This suggests that marijuana could or perhaps is a gateway drug. There's a lot more research that needs to be done on this topic, but it's something that could drastically influence the way our country views marijuana. Thank you for taking the time to listen to my video. If you're more interested in my specific research, data science techniques, or opioids, you can scan the QR code that's now on the screen to learn more, specifically through reading my 15-page research paper, or you can just use Google. Thank you so much. Have a great day.